Good. Hello. Hi there. Well, we're actually on time this time. Um, hello there. This is the 12th ACM general meeting. We're just going to go over very few things, mostly focusing on the ICPC. Since we've had slides in the past that were talking about how we do chocolate sales and we're also selling shirts, I'm going to just kind of briefly go through that. You guys don't need to hear it over and over again. But we are essentially selling chocolates for $1 if you're interested. Come talk to us. If you want to get a t-shirt, we're selling them for $10 if you're a member, $15 if you're not. Again, talk to us if you're interested. And we'll just go on to the next thing. So the next big thing is that we are having a barbecue at the end of the semester, so that everyone can get a chance to talk to other people, network with other clubs that are being involved. Just recently, SHIP, ACM, and I believe Computer Technology Club all doc funded for some money so that we can help put on this barbecue at the end. It's on May 19th, should be the last day on a Friday. If you're interested, also happy to give you more information. It's in development phase, but more details will come out as we go on. Mm-hmm. Everyone! Well, it is inviting everyone, but the main focus of it is for you to network with other clubs that are going there. All right. So besides that, we have the ICPC, which is this Friday. So we found out the location of the room. It's not in Riverside 1015. It seems that they had to move it to somewhere else. It's going to be in Sequoia Hall 360. So you meet up there. The main thing that we want to clarify is that the people that are judging asked for us to set the check-in time from 3 p.m. to 4 p.m. Anything beyond that, you will not be able to join in. You're able to have up to teams three, and you're also able to go in by yourself, and they would be able to help put you onto a team. So that's the main idea. If you're interested in knowing most of the rules for ICPC, I believe Matt is going to be talking about most of those today. But if you want to find out all the specifics, we have them listed here on our website at csusacm.org/ICPC. So I think that's basically everything I needed to was interested in mentioning today. Just clarification of location and when you get to check in. I think I'm going to also mention that we do have we met the amount of volunteers we needed, but if you're interested in volunteering, we're more than welcome to have you guys join us. Volunteer for ICPC. It looks good on a resume. You can put it down. Help us get the event going. There's always fluky stuff that happens there, and having more the merrier also helps. If you're interested in joining, we have a little Google form that you can sign out. We'll add you onto the list. Be happy to have you. So that's about it. I'm going to pass it over to Matt Merrill, who is going to talk a little more about the specific approach to doing ICPC from the competitive side. I'm going to pass it on. Thank you.
Okay. Hello. My name is Matthew Merrill. If you want to follow along or look at these slides later, they're available at this URL. Yes. So, ICPC. Who's been to the ICPC before? Cool. Who has not been to the ICPC before? Cool. So we got a few newcomers. So, of the people who have not done it before, are we planning on competing this year? Yeah? No? Yes. Yes. Cool. So this talk will just be about some of the basics of ICPC, what to expect, and some tips for success to get the most out of it. So let's start off talking about what it is. So it's a long competition and has a short pizza break intermission. And so when you first start the competition, you get a packet of problems, and every problem will have a programming related problem on it. So you'll get some input. You have to do something with the inputs, and then print something out for the output. So each problem gives you a balloon, and then the team who solves the most problem wins. And then there's some criteria for the deciding beyond that. It has to do with the time you submitted and the number of correct submissions. So here's a sample problem, like super basic problem that could be on there. Reading in. So the first number there tells you how many numbers you have to read in, right? So there's 3 numbers on this next line. And then for each of the numbers on this line, printing out the square of that number. Pretty straightforward. So so when you're in the competition, you're on the Linux machines that they provide. And so I like to use Eclipse for the Java. And here are the steps that I take to do so. Important notes is you don't want to have a package for your Java class. If you do, that'll mess up how the grading system runs it. I'm like 98% sure that you can have any class name you want, as long as your class name is the same as your file name. Of course, we're all familiar with that. And for those of us, sometimes I forget what the public static void main thing. So that's nice. You can have it automatically put that in for you if you're like me and you just want to get right to the coding. You don't have to type it all out. Yeah. So for reading into the screen, for reading in the input. So who uses Java? Who uses Java on the ICPC and uses Scanner? Yeah. Who does not use Scanner? Anyone use something different other than Scanner? So you could use someone. Yeah, you could use buffered reader. It's very similar. You could also just look at the input stream. So you could actually use systemin itself and keep calling next to get the next byte from the input stream. Scanner, of course, makes it easier. It sounds like we're all familiar with that. One bug that I've noticed, or not a bug, but a very confusingly documented feature, is that if you mix up next line and any of the other next methods, things get weird. Yes. So if you call next, or next int, say, if the int is at the end of the line, it'll read through the int, but it won't have read the new line character yet. And so when you call next line, it'll start at where you just finished, which was after the integer, and then it'll try to read until the next new line character. But of course, since that's like right there, you don't get anything back. So if you're expecting to get like the next line, it's not actually going to be the next line. It's just going to be empty. So I just, like, as a blanket statement, say don't mix next line with any of these other nexts. What you can do if you do have to mix them, you can say integer parse int and then next line. Yeah, so then you can turn the string into an integer. So this is like the same as this if it's on its own line. I guess the judges could be really mean and like completely mix it up. But yeah. But if the judges are nice, and like you'll see as you go, like if you look at like regionals or world problem statements, generally they'll give you like this number that tells you how many things you need to read in. So you won't need to do a has next or next lines or anything. So we can cross our fingers that we don't need to do like mixing, but so sending output, of course, we all know how to send output, right? Just system out print line. Yeah, so here's some tricks you can do. Sorting. Who here knows how to do a sort without writing it out themselves, like in Java? Yeah. So you can call sort on like a list of integers. If you do collections.sort, pass in the list. But if it's something that's not comparable, like integers or doubles, right? Those are like inherently, you can sort those. But if you have your own class and you can't really sort it, or if you have some other criteria you want to use, you can look into lambdas. If you are here for the lambda talk and you remember that, remember we can use lambdas for sorting. Or if you make your class comparable, right? So there are some neat ways to make sorting. Sometimes the problem, all it is asking you to sort something. And if you're familiar with different ways of sorting, it can be, it's super easy. So here's an example problem. Draw a house. So the input is the width of the house and the height of the house. Here at 7 and 4. This is saying that this part of the house is 7 wide and it's 4 tall. And then the roof should be going at a 45-degree angle until it reaches a point. Pretty straightforward. It seems like, every few locals there tends to be something like this. And it can be done with a lot of for loops, and it gets messy. That's where you have to debug and you have to figure out which for loop has the wrong, if you're incrementing instead of decrementing, or checking the bounds. But the first thing you should do is think about the different parts of the house, right? So we have this point up here that we can't really group with these, because here we have 2 things to print on this line. Here we have 1, so we might as well just print this one separately. We have this sloped part of the house we can probably do with a loop of some kind. We have this where just printing out, that's easy. This is pretty easy as well, right? So, use the scanner to read in the width and the height using nextInt. And then the point of the roof. So we can do it this way with a for loop, right? And so since this is like halfway into the width, it's just width divided by 2 that we want to print out that many spaces. But like I said before, I'd be showing you some ways to clean up the code. If you do it this way, you'll end up needing a for to print out these spaces, a for to print out each of these rows, a for for there, a for for each of these, right, 4 for those, 4 in here. That's nested inside a for here. So that's like 6 or 7 different loops, different places to go wrong. So what I like to do is make a method that I can pass in a string and I can pass in a number, and it'll give me a string that is that input string repeated that many times. So here's a simple utility method called repeat. So pass in a string and a number, and it just adds that many times and returns it, right? Pretty simple, pretty easy. There are more succinct ways of doing this, but I don't think that they will give you such large strings where this would break down. Yeah. So before we were doing the point of the roof with for loops, now we just pass in a repeat like that, right? The code is so much simpler, right? Just say I want that many spaces and a star. So we've made our what was 3 lines of code just one-liner. Yeah. So for the sloped part, looking at this, I like to use a while for this part because we can have the left pad, that's this left spacing, and the middle spacing in here. You could find some calculation to say base, here's the left pad, what is the middle part? And it would be like, I don't know, take the difference from w divided by 2, like divide it by something, and then like multiply by 2 or something.
Thanks, Matt. That'll be it for our meeting. Thank you very much for watching.